All right, so our focus is still solving those one-step equations, but the two operations that we're going to focus on this video is solving one-step equations that deal with multiplication and division. So our first problem says that the temperature rose a total of 10 degrees over 2 days. If the change in the temperature was the same both days, how much did the temperature rise each day? So they've already given us our equation, which is 2x equals 10. Remember, when we see a integer right next to a variable, that is multiplication. That shows us what is happening here. So we're going to draw our tiles. Now, this big dark line right here down the center still represents the equal sign. So none of that has changed. What is still true is our x tiles are still represented with the long rectangle tiles. Those are still our x tiles. But when we multiply and divide, the only type of tile that we use to represent our just regular numbers, it's only going to be the open unshaded circle. That's it. Because we're not subtracting anything, there's no need for the closed circle this time. So this just represents our digits, our numbers. Okay, so I still want to draw and separate what is on the left side of the equal sign and the right side of this equal sign. So when I cover up everything that's to the right, the only thing that's on the left is 2x. That's it. That's all I have. Now, I'm going to draw my x tiles a little bit differently. This time, I'm going to draw my x tiles sideways. So I need 2 of them. Now, here's why I'm going to draw them sideways, because I know that these 2x tiles, 2 of them have to be equal to a total of 10, which means I have to take these 10 and I have to split them between these 2x tiles. So I'm going to draw one at a time. So 1, 2, kind of like team captains that pick teams, right? You don't let a team captain pick all of their team members first and the other team captain pick all of their team members just from the leftover people. They have to alternate and they switch off picking their team members. So I gave 1 to the first one, 1 to the second one. That's a total of 2. So I'm going to go back to the top one for 3, to the bottom one for 4, top for 5, bottom for 6, top for 7, bottom for 8, top for 9, bottom for 10. So over here, I do have a total of 10 circles. And on the left side, I have my 2 x's. Now my answer is going to be just what 1x is worth. So I'm going to circle 1x and everything that is in the same line. So I have x equals 1, 2, 3, 4, 5. So one of those x's equals 5, which would make sense that then 2 of them would be 10. So let's look at how we would solve this algebraically. It's the same as yesterday, where I'm going to rewrite my problem, and I'm still going to make my upside down, or really just kind of my t-chart. We decided it wasn't upside down. Now, I still want to get rid of what's bothering the x, right? X needs to be by itself. And right now, what's bothering the x is that times 2. So I need to do the opposite of times 2, which would be divided by 2. And remember, what I do to one side, I have to do to the other side. So my 2's cancel each other out. So I'm left with x equals 10 divided by 2, which gives me 5. So I can check this by going back to my original equation, 2x equals 10. I'm going to substitute in 5 for x. So 2 times 5 equals 10. That is true, so it gets a check. For my graph, remember, I'm just going to put one single line. I'm going to call it what number I think x is. So x is 5. And I put a solid dot on there. Moving on to our next one. It just says use algebra tiles to solve, record our actions as we solve. So I have the problem is 3x equals 18. So remember, I'm going to start with what is on the left side, which is 3x. I'm going to draw my 3x tiles horizontally. So 1, 2, 3. And remember, these are like my team captains that are going to pick from these 18 players. So I'm going to start with the first team captain and give them 1. Second team captain gets 2. Third team captain gets 3. I go back up to the top for 4, 5, 6. Back up to the top for 7, 9, 8, 9. I can't count. That's not a good sign. Back up to the top for 10, 11, 12. To the top for 13, 14, 15, to the top for 16, 17, 18. Now remember, I only want to look at one of the x's. So I'm going to circle one of the x and everything that is next to it. So I get 1x is equal to 1, 2, 3, 4, 5, 6. So x equals 6. If I solve this algebraically, I'm going to start by rewriting my equation. So 3x equals 18. I'm going to build my t-chart. What's bothering the x right now is times 3. So the opposite would be divided by 3. What I do to one side, I have to do to the other side. So my 3's are going to cancel each other out. So I'm left with x equals 18 divided by 3, which gives me 6. In order to check, I'm going to rewrite my equation. So 3x equals 18. I'm going to substitute in what I think x is. So that would be 3 times 6 equals 18. That is true, so it gets a check. And then I'm going to graph. I'm going to put one single line. I'm going to call it 6, and I'm going to put a dot on 6. Let's look at one more together, okay? Our next one says that Darius has 9 Hershey's candy bars, and he wants to share them evenly between his 4 closest friends. What is x, the amount of candy that each friend will receive? So they gave me my equation, 4x equals 9. Let's draw this with tiles. So remember, I need what's on the left, which is 4x. Let's draw those horizontally. So 1, 2, 3, 4. So remember, these are like my team captains. They're going to get to share those 9 tiles. So I'm going to start with the top for 1, 2, 3, 4. I'm going to go back to the top for 5, 6, 7, 8. And then I need to get to 9, but I have 1 left over. So it wouldn't be fair to give the 9th player to that first team captain, because then it has more than the rest of the other team captains. So I have to think about, if I have this 1 player left, which really, that sounds horrible. I shouldn't call them players because I can't split up a player, but go with me. I have this 1 object left that I need to split between these 4 people. So I need to take this 1 piece, split it into 4 pieces, which means each person is going to get 1/4 of that piece. So they get a 1/4, they get a 1/4, they get a 1/4, and they get a 1/4. So again, I'm just going to look at one of these. So when I look at just 1x, I see that they get 2 whole pieces and 1/4. So x is equal to 2 1/4. So if I solve this algebraically, again, I'm going to set up my equation. 4x equals 9. Build my t-chart. So I know that what's bothering the x right now is this 4 times 4. So the opposite would be divided by 4. What I do to one side, I have to do to the other. So I have 9 divided by 4. So I'm going to come do this over here on the side. So I know that 4 goes into 9 2 times. 2 times 4 is 8. And when I subtract, I get 1 left over. And remember, I can stop if I'm keeping this in fraction form. So I get x is equal to 2. That's my whole number. 1 is my numerator. 4 is my denominator. So 2 1/4. To check, I'm going to write my original equation again. So 4x equals 9. I'm going to substitute in what I think x is. So 4 times 2 1/4 equals 9. I have a little bit of extra work to do on this one. 2 1/4 is a mixed number that I need to turn into an improper fraction. So to do that, remember, I do the good old 6's 2-step. So 4 times 2 would give me 8, plus 1 more would give me 9. So this is 9/4. And then 4, remember, it doesn't have a bottom, so I have to give it a bottom of 1. I can cross simplify. My 4's become 1's. And I know that multiplying fractions ain't no problem. It's the top times the top and the bottom times the bottom. So 1 times 9 would give me 9. 1 times 1 would give me 1, which equals 9. So this is true. Now for my graph is going to look a little bit different because I have a fractional part here. So I'm going to set up 3 lines. I'm going to call the middle line 2 1/4. Now 2 1/4 is in between, it's in the middle of 2 different numbers. It is in the middle of 2 and 2 1/2. So when I have those fractional parts, I just have to make sure that there's something behind it, something in front of it. But I'm going to put my dot right there on 2 1/4. Okay, so now we're going to look at how do we show division when we solve these one-step equations. So our problem says that Alyssa checked out some library books. 1/4 of the books were mysteries. Now remember, when we see that fraction next to the word of, that tells us that we are multiplying. So if she checked out 3 mystery books, what is x, the total number of books that she checked out? So we have our problem here, which is 1/4 x equals 3. You might be wondering, Miss Smith, you just said this was division, and yeah, I see multiplication right here. And you are correct. This is multiplication, right? If I'm multiplying times 1/4, that shows multiplication, but I can turn this into a division problem. So we know that multiplying by 1/4, it would be the same thing as dividing by the reciprocal. So instead of multiplying by 1/4, I can rewrite this problem as x divided by 4, because remember that's a fraction bar, that means division, equals 3. So I'm going to use this version of it just because it helps with my tiles just a little bit better. So I'm still going to use my same tiles. I still have my rectangle that represents the x and my open unshaded circles to represent what is on the other side. Okay. Now, when I have x divided by 4, that means I'm taking one x tile and I'm dividing it into 4 pieces. So if I'm going to draw one big x tile and I'm going to divide it into 4 pieces. Now, what this is saying is that when I look and I do x divided by 4, that each of those pieces is worth 3. So this piece would be worth 1, 2, 3. This second piece would be worth 1, 2, 3. This third piece would be 1, 2, 3. And this last piece is also worth 1, 2, 3. So that way, if I look at any fourth that is on here, they each equal 3. So I want to know what is the entire x worth. So that would be 3, 6, 9, 12. So algebraically, if I write this as x divided by 4 equals 3, I'm going to set up my t-chart. So remember, I want to do the opposite of what is bothering x. And since dividing by 4 is what's bothering x, the opposite would be times 4. So my 4's cancel each other out. So I'm left with x equals 3 times 4, which is 12. So if I wanted to check this, remember, I'm going to rewrite my original problem. So x divided by 4 equals 3. I'm going to substitute in what I think x is, and I think x is 12. So I just have to ask myself, does 12 divided by 4 give me 3? If it does, check. Last but not least, on my graph, I'm going to put one single line here. I'm going to call it 12, and I'm going to put a dot on it. All right, let's look at our next one. Our next one says that Susan made several batches of cookies for her daughter's birthday. 1/5 of, so again, there's that multiplication, that fraction next to the word of, 1/5 of the batches were chocolate chip. And if she baked 9 batches of chocolate chip cookies, what is x, the total number of batches that she baked? So again, they gave me my problem as 1/5 x, so 1/5 times x equals 9. I'm going to rewrite it to look like a division problem. So I'm going to get rid of the numerator of 1, and I'm going to switch it out for x. So x over 5, or x divided by 5, gives me 9. So remember, this means I'm taking one x piece, and I'm dividing it into 5 separate sections. So 1, 2, they don't have to be even, because Lord knows we're all human and we don't make things even all the time. We're not perfect, but just as close as you can. And remember, this is saying that each of those pieces, each one of those 1/5 pieces is equal to 9. So this 1/5 piece is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. This 1/5 piece is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. So is this one, 2, 3, 4, 5, 6, 7, 8, 9. So is this one, 3, 4, 5, 5, 6, 8, 9. And so is this one. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I need to figure out what the entire x is worth. So if this is 9, this would be 18, 27, 36, 45. So Susan made 45 batches of cookies, and I hope she shares with me. So let's solve this algebraically. Let's rewrite our problem. So x divided by 5 equals 9. I'm going to set up my t-chart. So the opposite of divided by 5 would be times 5. What I do to one side, I have to do to the other side. So remember, our 5s cancel each other out. So I'm left with x equals 9 times 5, which is 45. To check, I'm going to rewrite my problem. X divided by 5 equals 9. I'm going to plug in what I think x is. So 45 divided by 5 equals 9. That is true, so it gets a check. And last but not least, for the graph, I'm going to put one single line because it is a whole number. Label it as 45 and put a dot. Let's do one more together. All right, on the back, it says, Mrs. Tally has 8 cups of pink lemonade in a pitcher. If she wants to give each person 1/2 cup of lemonade, what is X, the total number of people that will receive lemonade? So we have our equation here. So 1/2 X equals 8. Again, I'm going to rewrite this. So X divided by 2 equals 8. I'm going to draw my tile. So again, I know I have one big X tile that I'm dividing in 2 pieces. And each of those pieces is worth 8. So this top piece is worth 1, 2, 3, 4, 5, 6, 7, 8. This bottom piece is also worth 1, 2, 3, 4, 5, 6, 7, 8. So my entire x is equal to 8, 16. If I'm going to solve this algebraically, I have x divided by 2 equals 8. I'm going to draw my upside down. Or really, it's not upside down. I don't know why I keep saying that, but I'm just going to draw my t-chart. The opposite of dividing by 2 is multiplying by 2. What I do to one side, I have to do to the other side. So I get x equals 8 times 2, which is 16. To check, I'm going to rewrite my problem. So x divided by 2 equals 8. I'm going to substitute in what I think x is. So 16 divided by 2 equals 8. That is true, so it gets a check. And then last but not least, for the graph, since it is a whole number, I just need one single line. Label it as 16. Put a dot on it.